We end section 2.3 with second and higher order derivatives. A new vocabulary word here will be nth derivative. And we begin here. The derivative y prime, which we know as dy dx, is called the first derivative of y with respect to x. Further, the first derivative might itself be a differentiable function of f. And if it is, then the derivative's derivative is y double prime, y with two prime notations, which can be written as dy prime over dx, which comes from the derivative with respect to x of dy dx. And the other notation is d squared y over dx squared. So all of these are separate ways to notate the derivative of the first derivative, which is called the second derivative. We also will see f double prime of x just as often as we see d squared y or y double prime. If y double prime is differentiable, then its derivative y triple prime, or the derivative of dy dx, which is d cubed y over dx cubed, often called f triple prime of x. That is the third derivative. So the point here is that often derivatives are differentiable themselves. And if that's the case, and if we have reason to find another derivative, then we name them first derivative, second derivative, third derivative, and so on. The names continue as you would expect, the fourth derivative, fifth derivative, and on, but the notation gets a little different. Rather than writing 5 or 6 or 7 prime markings after y, what we do is put the number of the derivative in parentheses in the exponent power. For instance, the sixth derivative of y would be y little parentheses 6, and that would indicate the sixth derivative. Or we might see f little exponent of 6 in parentheses of x. So that would be the sixth derivative. And these are all known as basically the nth derivative, the sixth, the seventh, the eighth, the ninth, the 10th derivative of y with respect to x. We see d ny over dxn, and don't confuse y to the exponent parenthesis n with y to the n. These are not the same. Y to the n is not the same as y to the little parenthesis n. So this indicates a derivative, and this indicates a power. So let's make sure we keep those two delineated clearly. And a little note at the bottom is essentially the same thing. D squared y over dx squared is not the same as dy dx squared. This indicates the derivative of y with respect to x times itself. This indicates the second derivative. Let's move on and see an example. Find the first 4 derivatives of y equals x cubed minus 5x squared plus 2. So let's start with the first derivative, y prime. By the power rule, we have 3x squared minus 10x. Then let's look at y double prime. We have 6x minus 10. Let's look at y triple prime. That would be 6. And then finally, y to the fourth prime, or y little parenthesis 4, this is going to be 0. So the other way to notate this is dy dx and d squared y over dx squared and d3y over dx cubed, and finally d and then little exponent 4y over dx to the fourth. And there we have the end of section 2.3.